Hello friends, welcome to my channel Skill on Tech. In this video, we shall discuss about how ejectors works. You might have already listened about steam ejectors and use of ejectors in other advanced applications such as refrigerations. In this video, we shall discuss working principle of ejector and its uses with simple method. Video become very interesting. Hence, please see the complete video. If you like the video, please share video with your friends and colleagues and kindly subscribe our channel. What is the working principle of ejector? Let us understand with a simple example. The operation of ejector is based upon Bernoulli's principle. You might have listened great scientist Bernoulli's name. Bernoulli has given a continuity equation for liquids A1 V1 equal to A2 V2, or for gases this is rho 1 A1 V1 equal to rho 2 A2 V2. Here rho 1 is a density. So this rho 1 A1 V1 equal to rho 2 A2 V2 is applicable for compressible fluids. When the speed of a fluid increases, its pressure decreases and vice versa. Let us see with the example. If you blow across the top of a piece of a paper, what happens? The air moving over the top of the piece of paper is moving quicker than the air underneath. Thus, the local pressure on the top surface of the paper is less than on the underside of the paper. The resulting pressure imbalance causes the paper to rise. This demonstrates the Bernoulli principle. Pressure energy. Here is a length of pipe which include a wall. This is wall. The pipe is arranged to discharge to atmosphere. At the point of discharge, there is a restriction or nozzle. The upstream side of pipe is connected to a pressure source. This is upstream side. This. The wall is closed, so there is no flow. When wall will be closed, there will not be any flow through the wall from this to this. Upstream of the wall, there is a pressure energy. So in the upstream side of a wall, there is a pressure energy. The arrangement is very similar to that of a garden hose connected to a domestic water tap. Energy conversion. When this wall is opened, this wall, the fluid can pass through the pipe. The fluid can pass through the pipe from here to here and be discharged out of the nozzle from this nozzle to here. There is a pressure on the upstream side of the nozzle. Here in this side there is a heavy pressure. A jet of fluid moving faster than the fluid within the pipe emerges from the nozzle. So here the velocity of this jet is faster than the velocity in the pipe. What we have seen in earlier slide, that pressure energy converted to kinetic energy and velocity of fluid is increases. So what is the impact of this on surrounding air? Now if we were able to see the surrounding air in the region of the nozzle, here nozzle discharge, we would see that there would be eddy currents of air circulating around the jet. Here eddy currents of the air circulating around the jet. In other words, the jet of fluid emerging from the nozzle has imparted some of its kinetic energy onto the surrounding air. You can see in the picture, here it is a pressure, so this is a pressure energy, and this pressure energy converted from here to nozzle into a kinetic energy. Velocity of this fluid is increases. So here you can see these are the entrant gases. So due to this velocity in the surrounding, pressure decreases and a vacuum is created here in the surroundings. What is the effect of pressure drop around the nozzle? Let us see with a diagram. Suction around nozzle. If we then placed a tube with open ends around the area of nozzle discharge. Now this is a tube. This is a tube we have placed. This tube. We would see that the eddy currents had disappeared and that have been replaced by a steady flow of air moving through the tube in a direction from left to right, from here to here, as shown in the diagram. Here this is a pressure energy, is converted into a kinetic energy, and here due to pressure drop the vacuum is created and gases are enter from here and started flow along the jet. Ejector design. You can see a picture of a ejector. If we then blank of the upstream end of the tube and added a side inlet. This is a side inlet. Side inlet. This is tube is closed, blank from this side. We would see that the air would be sucked in through the side inlet. So air would be sucked in through this side inlet and discharged from the end of tube and discharged from here, end of the tube. We now have a simple device that is capable of pumping the surrounding gas. This is a very basic form of an ejector. So here in this ejector, here this is a high pressure motive gas which goes through here. Here it is a nozzle. So this pressure energy converted into a kinetic energy, and due to this change in pressure energy, from here pressure drop will be there and suction will be from this side, and this will also come along with this jet and will be discharged from this diffuser. This portion is called diffuser. This portion is called diffuser. Here area is increasing and this is a throat of steam jet ejector. There are three connections. One for the high pressure HP motive gas. So here this is a high pressure HP motive gas, and one for the low pressure LP suction. This is a low pressure LP suction entrant, and one for the medium pressure discharge. This is a discharge. The suction in this case gas comes in at the side. So this is a gas which will come from here, from this side. There is a nozzle for converting the pressure energy of high pressure motive into kinetic energy. So this will be a high pressure will enter here in this nozzle, and from At this place, it will be converted from high pressure energy to kinetic energy. So the suction, here pressure drop will be there, and this suction will also come along with this HP motive. That can be a steam. So this is generally HP motive is a steam. So therefore this is called a steam jet ejector. Pressure and velocity profiles. You can see a picture of a steam jet ejector. This here it is a high pressure entry of a steam. So there is a high pressure, and in this nozzle this pressure energy will be converted into a kinetic energy. So velocity will be high here and pressure will be less. And again, after this throat, ejector diffuser throat, the area of diffuser is getting enlarged. This area. So again, the velocity energy will convert into a pressure energy, and little pressure will be gained again in the diffuser as cross-sectional area of this diffuser is getting increased. So when area will decrease, kinetic energy will increase. So this is a throat. Here also in the nozzle, the velocity just after exit of the nozzle will be very high and pressure will be less. So similarly it is shown here in this picture. In this picture, this velocity profile of the steam ejector. What are the uses of ejectors? Let us know. To inject chemicals into the boiler drums of small stationary low pressure boilers. In large high pressure modern boilers, usage of ejectors for chemical dosing is not possible due to their limited outlet pressures. Jet pumps have been used in boiling water, nuclear reactors to circulate the coolant fluid. For the bulk handling of grains or other granular or powdered materials, the construction industry uses them for pumping turbid water and slurries. Some aircrafts, mostly earlier designs, use an ejector attached to the fuselage to provide vacuum for gyroscopic instruments such as an attitude indicator, etc. Thanks for watching the video. If you like this video, hit like button below and share it with your friends and colleagues. Subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.